Okay, good morning everyone, and thank you very much for joining us. I'm Beck, the event manager at Great Southern Press, and we have Gareth here. Thank you very much for your presentation. So Gareth's here to answer any of the questions you've got. A huge thank you to Stats Group for presenting and sponsoring the event. If anyone has any questions, you should see on the right-hand side of your screen, you've got the live Q&A section. Just pop your questions in there and I'll read them out for Gareth for him to answer. So we've got some questions already, which I'll read out to you, Gareth.
Yep.
How do you select the materials for the DBL valves?
All right, well, I'm assuming this is just relating to the Stats double block valve. So it's a standard design for us, which is just made up of steel and HMBR seals, which are on the inside for where we can test between the seals to prove that it's double block. But it's nothing too fancy other than steels and rubber. So.
Cool. And are there any FMECA details available and any common mode of failure identified for the redundant systems?
Yeah, so we've obviously done an FMECA as part of our DNV type approval for the system. Now, whoever asked the question, by all means, as a follow-up, my contact details are there. What we probably advise is having a single session to go through the system and just discuss each of the failure modes if you want to understand that more. But some of the failure modes you could probably go through are if you if you had a failure of one of the clevis arms, we've got a second clevis arm which is capable of retaining the full load. If you were going to lose pipeline pressure, both seals are fully energized by the hydraulic pressure. What else could be as an example? If you were going to have failure of the secondary seal, you've got the primary seal, which is obviously going to maintain isolation. Again, failure of the secondary seal, you've got failure of the primary seal, which would be able to maintain isolation. So we've got an array of FMECA data that we have done, but we can definitely have a follow-up session with the person that asked that.
Oh, Gareth, can you move your camera down a little bit? There we go.
Right.
What is the maximum lifetime of the polymeric seals? This will depend upon the environment and conditions. How do you deal with these to define its lifetime?
Yeah, so as part of every job, what we do is we collate all the information from the client. So that typically starts with a questionnaire, which will give us all information with regards to product composition, pipe wall thickness, pressures, design pressure. And then what we'll assess is obviously the duration of the isolation as well. So our engineers will work together and look at, can we use a standard HMBR rubber compound for or do we need to look at maybe a softer compound or a harder compound? So the longest we've done in situ is 7 months, as per one of the case studies that we did, but we can extend that further. The seals have got a longevity in terms of lifetime, but what we do is review it up front. If we need to do some testing, we would do, but again, it's one of those things that we just have to review the client spec, and then we would come back and say, if you want to have a long-term isolation, you could do this. We've looked at applications in the past where it could be 2 or 3 years having a bicep in place.
Are there limitations of flow rate or velocity when using the bicep as a dual set? And what is the effective restriction to the flow?
For the dual set, again, it's one of those things we just need to review every application in its hand. I mean, in the presentation, I said that we had probably a max DP around about 80 bar. Now, that is based on sort of standard flow rates where we're saying if you've got 2 dual sets in, it'll be 5 meters for gas, or it could be 5 meters for oil or 10 meters for gas lines. That's predominantly focused around the hot tap, because when we put in the bicep, the flow can obviously go somewhere. But what we also need to look at is the pressure, where if you have a liquid lines, how that liquid could go against the back of the bicep head. So we don't have a rule of thumb for that. It's just something our engineers need to take based on the pipeline specification for the client.
Cool. Now, Gareth, there's been some other questions asked. Can you see them in the portal there? So we've got, how does the DBL manage uneven surfaces that may lead to leakages?
Yep. So I'm assuming this is regarding for the bicep, or it could be for the valve. My apologies. But for the bicep, I think, as I mentioned in the presentation, it's with regards to API 5L tolerances. So that's when really covering sort of the ovality. But when you actually put the bicep head into place, the head will sit, horizontal in the pipeline. And then once we actually set the head will retract so it becomes smaller and everything will grow out the way. So this is where the seals, because they cover quite a large radial space in the pipeline, the seals themselves will embed in the sort of corroded pitted pipework. So we've got a long section of rubber, which is going to be able to go up and down, potentially explode into one where it could be lower or a section which could be higher. Obviously there's a min and a max, and the head will only stroke as far as it can be, but that's one way which we mitigate sort of that sort of corroded pitted pipework.
And then Nick has asked, can you give us some more information on the agreements that's recently reached with Santos?
Yeah, so quite a big milestone for the company. So we've just recently signed a long-term agreement with Santos to cover a large section of their pipeworks across Queensland, South Australia, with the option to grow that further, but really focusing on our bicep technology and our other technology, which is called the Technoplug. So for a lot of their upcoming work scopes where they don't want to depressurize, Santos have really bought into, one, the technical advantages that we can provide, and two, the max cost savings that we can give, be that by less time on site. So it's something that we've got our first project with them, which will be Q1, Q2 next year, which is looking at using the DS bicep at 3 locations across one of their sites in South Australia. So it's quite an exciting chapter for the company.
I had another question coming before, and it was, how long did Stats take to develop the technology?
So the way the technology developed was Shell in the North Sea back in 2008. They actually came out to the market and said, look, we understand there's current technologies where you have, you can do one hot tap and you can enter one lip seal line stop, but we really need to, down some of our riser legs offshore in the North Sea, we don't have the space for that. So we really need to have one system which can give us double lock and bleed. So back in 2008, probably around about over a 6 to 12 month period, we developed the technology. And that's how from that one project it's grown out to be a standard product that's going across the world now. So from 2008 onwards, it's been sort of going through a lot of standardization, but now we've got considerable mass of assets between all of our regions here where we're responsive based on time and where the client is.
Yeah. And does the process or tooling change at all for the multivariate diameter pipeline?
Could you repeat that, sorry?
Does the process or tooling change at all for a multi or varied diameter pipeline?
I don't know if the question's very niche. You've got one pipeline which goes from say 24 to 28, but basically as a tool goes up in sizes, it's basically a core and a kit. So one 14-inch system which we've got, the core of it can potentially do a 12-inch pipeline and can potentially do a 16-inch pipeline, just on how we dress the system up. So that's one of the things that we've noticed for Australia is that there's quite a common theme of those pipeline sizes between 12 and 16. So we've actually put a lot of considerable investment in, right, how can we optimize the equipment? So one of our 14-inch tools is going to be able to cover a range of sizes, which are basically from 12 up to 16.
Okay, and I've got one last question here. Do you foresee any more improvements or modifications that can be made to this technology?
Well, that'd be probably a question for one of the founders of it, but I'm probably trying to say that what we just touched on there in terms of how we can optimize the current equipment. And so as we're looking to, be more cost effective, and obviously in this current climate to look at optimize pricing, the way that we can get our equipment to cover more pipeline sizes without having to always just have one size fits all, that will mean that we can, have equipment be left in regions where it can cover the majority of pipeline size without having to always maybe have equipment coming from a different facility or from outside the country. So that's probably some of the more developments that we're looking at, just to optimize one size which can do more pipeline sizes.
Yeah, cool. Well, Gareth, thank you so much for joining us here today and for the presentation. Thank you everyone that's online as well for joining us. If there is anyone out there who is interested in presenting a webinar, please feel free to get in contact. Again, a huge thank to Stats Group for being the first ones to be here for the Australian Pipeline webinar series. And everyone, don't forget to click back to the timeline and just complete the feedback survey. and have an awesome afternoon for everyone. Thank you.
Thank you very much.